So this is our particle motion problem. We have two particles moving for times 0 to 8. Now they give you different equations, so just be careful. They give you the position equation for particle P, but they give you the velocity equation for particle Q. So this one is position for particle P, velocity for particle Q. And then they give you an initial condition for particle Q, that's where the particle is, and they started at time 0, which is nice. All right, so it starts at 0. So letter A, for times 0 to 8, when is particle P moving to the left? Moving to the left means that velocity is negative. Now, they don't ask for an explanation, but if you were supposed to put one, you would get your answer and say, because velocity is negative there. So moving to the left means velocity is negative. So we're going to have to get the velocity function, which is going to be the derivative of position. So this is a chain rule, derivative of the outside function, which is ln, and then we'll chain on the derivative of the inside stuff. So derivative of ln is 1 over x, but it's 1 over whatever you've got. So in this case, 1 over all of that stuff. And then you have to chain on the derivative of that stuff, which I'm just going to go ahead and put in the numerator. So derivative of this guts of the problem would be 2t minus 2. Sorry, I'm trying to respond to people in the chat. I'm sorry, I'll respond to you after. All right, so there's our velocity. We want to see where this is negative. So I'm going to factor the 2 out of the numerator just to make this a little bit easier. You don't have to do that. That's kind of personal preference. The denominator doesn't factor. So it would either be positive all the time or negative all the time. This got moved up. If you look at just the denominator, t squared minus 2t plus 10, that would be a parabola that got moved up 10. That's going to be above the x-axis all the time. So you can make a number line for that if you want, but it's going to be positive all the time. Same with 2. 2 is just 2. It's a positive number. It's positive all the time. So I'm just going to make a number line for the t minus 1. Again, you can write number lines for these two factors as well. They'll just have pluses the whole way across. So it's kind of not necessary. So this is going to be negative and then turn positive. And so we want where velocity is negative. So this velocity is moving to the left from 0 to 1. Remember, we don't have negative time. So 0 to 1. So moving left from 0 to 1. And you don't have to put a reason, but if they asked you to justify, it would be because velocity is negative there. I think you're going to do a lot of justification, things like that for this exam, because they're going to have you type in your answers in words. All right, letter B. For times 0 to 8, find all times during which the two particles travel in the same direction. That means their velocities are the same sign. So they're either both positive or both negative. Now we already have, and I guess I can cap this at 8. They said from 0 to 8. I already have a number line for particle P. We're going to repeat this process for particle Q and then compare the number lines and see where they are the same sign. So again, both positive or both negative. Now you don't have to do a derivative for particle Q because this already is the velocity. They gave us the velocity. I'm just going to factor that. That would factor into, gosh, what, t minus 3 and t minus 5. So I'm going to make a number line for t minus 3, number line for t minus 5. And again, I can cap this at 0 to 8. That's what they made our interval. So this one's going to change at 3. It'll be negative and then turn positive. This one's going to change at 5. Again, it'll be negative and turn positive. So if you slice up your number line, negatives cancel. So we would be positive, and then this middle section is negative and then positive. So we need to look at where these are the same sign. So they move in the same direction. And let's compare. All right, from 0 to 1, particle P is moving left. Velocity is negative. From 0 to 1, I know 1 isn't on here, but 1 would be like right about here. From 0 to 1, particle Q is moving in the positive direction. So from 0 to 1, this one's negative and this one's positive. So we don't want that section. All right, from 1 onwards, particle P is moving to the right. Velocity is positive. So let's see, from 1 to 3, particle Q is also positive. So they're both positive from 1 to 3. And then also from 5 to 8, they are both positive. So same direction, 1 to 3 and 5 to 8. And again, they didn't say justify, but if they did, it would be because velocities are the same sign there. All right, letter C. Find the acceleration of particle Q at time 2. Is the speed of particle Q increasing, decreasing, or neither at time 2? This one they do want a justification. All right, so they asked for a lot here. First, let's find the acceleration of particle Q. And so usually they put like, yeah, let me see, they put like a little sub Q there. So it's A of t, but specifically for particle Q. So if this is velocity, to get acceleration, we're going to do the derivative. That would be 2t minus 8. And they said, find the acceleration at time 2. So we're going to plug in 2 to that. If you plug in 2, you get 4 minus 8, which is -4. There were no units given in this question, but if there were, like say it was feet per second, an acceleration would be feet per second squared. So just be aware of that. I'm just bringing up the units in case they give you a question that does have it. The other thing they ask you for is the speed increasing, decreasing, or neither. This is so commonly missed because people will just look at the acceleration. You have to look at velocity and acceleration. If they are the same sign, your speed is increasing. If they are the opposite signs, your speed is decreasing. If you are in a car and you're moving forward, you have positive velocity. And if you're hitting the accelerator, you have positive acceleration. You're speeding up in the positive direction. But if they're both negative, you're still speeding up. And the example I always use is if you jump out of an airplane, you're moving downwards, that's negative velocity, but you're accelerating towards the ground due to gravity. You have you have negative acceleration. You're speeding up in the negative direction. You have to look at both, right? So our acceleration at 2 is negative. We need to get our velocity at 2. So if you plug 2 into velocity, let's see, that would be 4 minus 16, so -12 plus 15 would be 3. So we would say speed is decreasing at time 2 because v of 2 and a of 2 are opposite signs. So speed is decreasing at time 2 because v of 2 and a of 2 are opposite signs. So just remember, when they ask you for speeding up or slowing down, you have to look at both velocity and acceleration. You can't just look at one, you have to look at both. All right, and then letter D, find the position of particle Q the first time it changes direction. All right, so first let's figure out what time that is. And actually, I just folded the paper over. Now I'm going to bring this back. Particle Q, when we factored that velocity, we got t minus 3 and t minus 5. So the first time that it changes direction is at times 3. It goes from a positive direction to a negative direction. So times 3 is the time that we're talking about. And it says find the position of particle Q at times 3. That's the first time it changes direction. So it starts at 5. This is going to be initial condition plus displacement. And if they give you an initial condition, you're going to use it. That's never extraneous information. Sometimes they do give you extra stuff, but never that. You will always use an initial condition. So if you do the whole problem and you never use this, go figure out where it goes because it's going to go somewhere. All right, so 5 plus, and we are going to start at 0. We want to go to 3 for this velocity. And so once you get it set up, then it's just a matter of working that out. All right, so 5 plus this antiderivative, 1/3 t cubed minus 4t squared plus 15t. We're going to evaluate from 0 to 3. And so it's upper boundary minus lower boundary, but the lower boundary is just going to be 0. So you actually don't even have to write that. And if you plug in 3 cubed is 27, a third of that is 9. 3 squared is 9 times 4 is 36, and then 15 times 3 is 45. You don't even have to simplify it that far, though. You could leave it as 1/3 times 3 cubed minus 4 times 3 squared. You don't even have to simplify it down. It's free response. All right, so points for this one. Let me see, what did they give you? It was a point for getting this velocity. So if you did that derivative, you got a point. And then it was a point for the answer. All right, and then in part B, it was a point for the answer, but then it was a point for doing this analysis. So you needed to look at the velocities of both of them. So I don't know where to put that one, but it was a point for the analysis. You had to analyze, right? In part C, it was a point for getting this acceleration at time 2, and then it was a point for your answer with justification. So what am I at? 6 points so far? Yeah, and then the last one is worth 3. You get a point for using the initial condition. So if you wrote 5 plus bananas, you got a point. It was a point for the antiderivative, which that was a pretty simple antiderivative, and then a point for the answer. Easy and difficult is always an opinion thing, but my opinion is part D was the easiest part of that, because that was a real simple antiderivative. It wasn't too bad.